In this module, you will learn to find the distance from a point to a line and the distance between two parallel lines. Consider line L and point P in a coordinate plane. The distance from point P to line L is equal to the length of perpendicular PM drawn from point P to line L. Let this distance be D. Let line L be represented by the general equation of a line AX plus BY plus C is equal to 0. Let the given line intersect the X and the Y axis at points Q and R, respectively. The coordinates of point Q are obtained by solving the equation of the line and the equation of the x-axis. That is, y is equal to 0. On solving, we get the coordinates of point Q as minus c upon a comma 0. The coordinates of point R are obtained by solving the equation of the line and the equation of the y-axis. That is, x is equal to 0. On solving, we get the coordinates of point R are 0, minus c upon b. Let us join PQ and PR to form triangle PQR. Recall that the area of a triangle is equal to 1/2 of the product of its base and height. Thus, area of triangle PQR is equal to 1/2 of the product of its base QR and height PM. Let this be equation 1. From equation 1, we get distance PM is equal to twice the area of triangle PQR divided by length QR. Let this be equation 2. Recall the formula for the area of a triangle whose vertices are given. Substituting the coordinates of vertices P, Q and R in the formula for the area of triangle and simplifying, we get the area of triangle PQR as 1/2 into modulus of C upon AB into modulus of AX1 plus BY1 plus C. Let this be equation 3. Therefore, twice the area of triangle PQR is equal to modulus of C upon AB into modulus of AX1 plus BY1 plus C. Let this be equation 4. Now recall the formula for the distance of a line joining two given points. Substituting the coordinates of Q and R in the distance formula and simplifying, we get the value of QR as modulus of C upon AB into under root A square plus B square. Let this be equation 5. Let us substitute the values of twice the area of triangle PQR and length QR from equations 4 and 5 respectively in equation 2. On simplifying, we get the value of PM as shown. Recall that PM is equal to the distance D from point P to line L. Thus, the distance D of a point X1, Y1 from a line AX plus BY plus C is equal to 0 is given by modulus of AX1 plus BY1 plus C divided by under root A square plus B square. Now, let us find the distance between two parallel lines, L1 and L2, in a coordinate plane. Since lines L1 and L2 are parallel, their slopes M must be equal. Thus we represent line L1 as y is equal to mx plus c1 and line L2 as y is equal to mx plus c2 in the slope-intercept form, respectively. Note that the intercepts c1 and c2 must be different. Otherwise, the two lines will overlap and the distance between them will be 0. Let line L1 intersect the x-axis at point P. Since point P lies on the x-axis, its y-coordinate is equal to 0. Substituting this value of y in the equation of line L1, we get the x-coordinate of point P as minus c1 upon m. Therefore, the coordinates of P minus c1 upon m, 0. The distance between lines L1 and L2 is equal to the length of the perpendicular drawn from point P to line L2. Let this distance be d. Recall the formula for the distance of a point from a line. The equation of line L2 in general form is minus mx plus y minus c2 is equal to 0. Comparing the rearranged equation of line L2 with the general equation of a line, we get the values of a, b and c as minus m, 1 and minus c2 respectively. Substituting the coordinates of point P and the values of a, b and c in the formula, we get equation 1 that gives the value of distance d as modulus c1 minus c2 upon under root 1 plus m square. Equation 1 gives the distance between two parallel lines L1 and L2, whose equations are given in the slope-intercept form. Suppose the equation of the parallel lines L1 and L2 are given in the general form as shown. Rearranging the given general equations in slope-intercept form, we get equations 2 and 3 representing lines L1 and L2 as shown. Comparing equations 2 and 3 with the slope-intercept form of the equation of a line, we get the slope of the parallel lines L1 and L2 as minus a upon b, and the values of the y-intercepts of lines L1 and L2 as shown. Recall the formula we derived for the distance between two parallel lines whose slopes and y-intercepts are known. Let us substitute the values of slope m and y-intercepts c1 and c2 in the formula. On simplifying, we get equation 4, which gives the value of d as modulus c1 minus c2 upon under root a square plus b square. Equation 4 gives the distance between two parallel lines L1 and L2 whose equations are given in the general form.